David Smith here with yet one more flipped classroom math lesson. 3 tips before we start. First, remember that you can slow down or speed up the playback to suit your needs. Second, you can pause the video at any point to catch up with your notes or jot down questions. Third, you can turn on the captions and read my words on the screen. Today, we're going to begin our first in a series of lessons dealing with how to present data. And a lot of these presentations, in fact, most of these are all about graphical means for presenting data. And graphical means are super important and super helpful. Tables and columns and lists of numbers, while they tell a lot, they don't show it in a graphical way, like what the most is. You have to really read the numbers to tell what the most is. With a bar graph, it's pretty simple. The highest bar on the graph is the most. So whenever we present data and we're trying to make a point or a sales pitch, we always want to use graphical means just to make our points super clear. Okay, so today we're going to talk about bar graphs and histograms. And these are two methods that are fairly similar, but there are some important differences and you're going to want to know them. So when you get a question on a quiz or a test, you create the right graph. So let's take a look at a frequency table first, because basically all these things are based on frequency tables. So here is a table showing dog age, right? So we've got all these ages all the way up to 16. And then the frequency is how many dogs we measured that had that age. So we had 10 dogs that were 1 year old, 8 dogs that were 2, 16 that were 3, and so on. So let's take a look at this data in this table and see if we can tell some things about it. First off, you can see, and this is what you might expect, most of the dogs are right in this zone here, kind of ages 1 to 8. And we know this, that dogs, that's a good lifetime length for a dog, maybe 8 years. But plenty of dogs live longer, especially the littler ones. So we can see that we do have dogs that are living all the way up to 16. And I'm sure some of you out there who've had a pet dog that's lasted more than 16 years. It's not uncommon. But we can see the bulk of our data is in this sort of 1 to 8 year range. And that makes sense. So we can get that from our table. But now we're going to make, from our frequency table. Now we're going to make a bar graph. All right, let's take a look at a bar graph. Now, before you pause the video and laboriously copy this bar graph down, let me talk about it first. And then you decide if you need to take the time to get a good copy in your notes. You are going to create some of these in the homework or in the exercises, so you'll get your practice there. But if you want your notes to be a good record of the lesson, then you will put this in there. Okay, so a bar graph graphs the data numbers versus the frequency. So my horizontal, my x-axis, is the dog's age. Okay, so I got my 1 through 16 along the horizontal x-axis. Then the frequency is how many times each of those ages showed up in our data. And so that's the frequency column in my table. So this is why this is called a frequency diagram. It's a bar graph, but it really is a frequency diagram, whereas this is a frequency table. And it does some nice things for us. Remember how we talked about where the data was concentrated in the first 8 years? Well, guess what? You can see that pretty clearly in the table that during this time we have the highest frequencies of our ages. And that tapers off as you go further along, which makes sense. Fewer and fewer dogs are going to live that long. So generally my graph, if I curved it, I could make a curve that was up and then it would taper off out to maybe 25, 30, I don't know, some dogs live pretty long. All right, now let's talk about what makes this a good bar graph. Fairly similar to a histogram, but there are some important differences. First one, always with all of these graphs, any graph you make anywhere, you need to label your axes. If you don't do that, the graph kind of struggles with being meaningful. So my horizontal axis is dog years. I put dog age in years. Okay, so that's really clear what's going on with that axis. And then it's sufficient to put frequency for the y-axis, the vertical axis. So there's my axes that they're labeled. Now here's an interesting one. The bars straddle the numbers, okay? So I've got an individual bar. It doesn't touch the next bar, okay? So often people make bar graphs where the bars are all touching. Technically speaking, if you're asked for a bar graph, you need to make your bars separate from each other. Now, it's not a requirement that you shade them, but I think that helps a lot. Otherwise, this zone in here ends up just looking like a lot of vertical lines. Kind of hard to tease out what the bar is and what the bar isn't. So bars straddle the numbers. Another way to say that, or another thing, is that they don't touch each other. So notice how the bar is straddling the 1 or the 2 or the 3. The number is directly below the middle of the bar, and the bars don't touch. Important, important, important. Make the bars the correct height. Don't just wing it. Actually take a look. Make sure that if this one lines up with 10, that we had 10 dogs that were age 1, and guess what? I can look back at my table and I can confirm that that's true. So make your bars the accurate height, and then overall with any diagram that you make, it should be neat and accurate. It should faithfully represent the data. Now, if you're being super thorough, if this was a report and you're doing a study on ages of dogs, you would provide the frequency table as well as the bar graph. That allows people to look at it in table form and in a graphical form. Okay, let's look at another chunk of data. This time we have race times in seconds from 11 to 12, 12 to 13, so on, all the way through these ranges, these classes of times, all the way to 20 to 21 seconds. That's our last class. Now, if you look at the frequency table, you can see some things here. We have some central tendency, just like we did with the dog ages. We have right in here, these 3 times, 13 to 14, 14 to 15, and 15 to 16, they are higher than anybody else. So we know like our central tendency is going to be somewhere in here. In fact, we can see the modal class, that's 14 to 15 seconds. And our mean and our median are probably going to be somewhere in this zone as well. Okay, so now we're going to make what's called a histogram based on this data. All right, I got the graph started, but then I'm going to walk you through making the bars because it's a little bit complicated. So first off, I did the same thing for my axes. I labeled them, I marked them off in my units. My time goes from 11 to 21. Notice how I put this little deal there. What that symbolizes is the fact that there's some time that I'm not showing, namely 0 to 10 seconds. My data starts at 11, so putting the first 10 seconds in my histogram without any data for it would just use up some space. But we want to use this little device here to indicate to the people looking at our histogram that we've left that out. And then I've got my frequency going all the way up from 1 to 10 because 10 is my highest frequency. Okay? So my classes are here, 11 to 12, there's one class, 12 to 13, 13 to 14, and so on. So graphing, I want to, first off, I remember my title, good job, David, and then all the other things that were on the bar graph, or most of the other things, are important, like labeling your axes, making sure it's accurate. But now we have some rules about the bars for a histogram that are different. The bars connect to the numbers and the bars touch. So I'll start putting in the bars and show you what that means. So my first class is 11 to 12, the frequency is 2. So what I'm going to do is I'm going to make my bar go up to 2, go across, and down. So with the bar graph, the number was in the middle of the bar because that data was discrete and it represented all the 2s. So we kept the bars separate and we made them discrete. Now, this bar represents a class. It represents the class of times from 11 to 12. So we connect the end members of the class and draw a bar that indicates that class. Now the next thing, remember here the bars touch. So if we draw our second bar, 12 to 13, that goes up to 4. So I can just continue this line here, scoot up to 4, go across, and come down to 13. So that's my second bar. Now notice how they are touching, okay? Now what I want you to do is go ahead and pause the video and finish that graph. If you haven't started putting it into your notes, now's the time to do that. Get this in there, and then go ahead and make bars for the remaining modal classes. All right, go ahead and compare your graph to mine. I just continued the process and made my remaining bars, and there's my histogram, okay? So you can see bar graph and histogram are very similar, okay? But there's some key differences. One, the bar graph straddles the numbers, whereas the histogram connects the numbers. The bar graph has bars that don't touch. The histogram have bars that do touch. The bar graph is best suited for discrete data where you have individual values, not ranges of values. The histogram is best for ranges or classes of values. Okay? So that's a summary of bar graphs and histograms. Now that you've watched the video, jot down some notes or questions for our next class. You can also re-watch the portions of the video that you didn't understand so well the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.